Sections 3.3 and 3.4 are again on exponential functions, but I literally can't remember the last time we talked about exponential functions. So I think maybe first we should recall some things from class. Maybe a few definitions. So first of all, what is an exponential function? We had a definition. An exponential function is of the form f of x equals c times a to the x. That doesn't look like an a, does it? Let's rewrite that. C times a to the x. Okay. So a few things on notation here. If a is bigger than 1, we say that f of x is an exponential growth function. And if a is between 0 and 1, so it's less than 1 in particular, we say that's exponential decay. Okay, so in this definition, there were a few important things. One of the important things was what this value c is. So c is just a number. And it happens to be the y-intercept, or the initial value. Okay, and we also had this number a. So what's going on with a? So first of all, since a is being raised to a power, we call that the base. And we'll talk about logarithms later this week, so that'll be a whole bunch of fun. We'll talk more about what this means, but a is the base. In terms of f of x, we call it the growth or decay factor. So it's the value by which f of x is multiplied by when x increases by one time period. If you don't remember that from class, it's all right. There's like a few notes from section 3.1 and 3.2 that we did do in class. If you're having trouble with this, I suggest taking a look at that. And there's one more thing I want to talk about, which is the growth rate. We also defined this in class, but for an exponential equation, the growth rate is the growth rate, let's call it R, is given by So we'll have that a is equal to 1 plus r. So if we want to solve for r, this is just a minus 1. And when r is bigger than 0, we have exponential growth. And when r is less than 0, we have exponential decay. So really quickly, an example of each of these might be for exponential growth. What if we have a equals 1.05? So 1.05 is bigger than 1. So from what I just told you, this means we have an exponential growth function. And then if we solve for r, r is equal to a minus 1. So in this case, r is equal to 0.05. And we see that r is indeed a positive number. On the other hand, for exponential decay, maybe I have a equals 0.85. So 0.85 is between 0 and 1, so that means we have decay. And r is going to be equal to 0.85 minus 1. So that'll be negative 0.15. And we do get a negative number for r. Okay, so if any of this is causing you issues, I would either pause this video right now and go look at section 3.1 and 3.2, or maybe take a look at the textbook. It's been a while since we looked at this stuff. So yeah, let's move on to problem 1. So we're given two functions here. Let's see, can I get this in the, there we go. F of x is equal to 5 times 1.06 to the x, and g of x is equal to 7 times 1.02 to the x. And let's remember that an exponential equation looks like, well, let's say y equals c times a to the x. Okay, so the first question is, which function has a larger growth rate? Remember, growth rate was r, which was 1 minus a. So let's calculate those. You can probably tell which one's going to be bigger just by looking at it, but let's do the growth rate for f of x and the growth rate for g of x. So r is equal to 1 minus 1.06, which is 0.06. That's the growth rate for f of x. And over here, r is equal to 1 minus 1.02. So we get 0.02 is the growth rate for g of x. So which one of these is larger? It's 0.06. So f of x has a larger growth rate. Wow, very exciting. Super exciting stuff. All right, which function has a larger y-intercept? So remember that c was the y-intercept. So the y-intercept for f of x is going to be 5, right? It's just the number out front of the exponent. And the y-intercept for g of x is going to be 7. Which one of these is bigger? 7. So g of x has a larger y-intercept. And finally, using our answers from parts 1 and 2, will the graphs of f of x and g of x intersect when x is bigger than 0? Why? Or why not? So, spoiler alert, yes, they will intersect. So I would think of this in the following way. Although g of x has a larger y-intercept, so it starts off bigger. It has a smaller growth rate. So how do I want to write that? Has smaller growth rate. So eventually f of x will overtake g of x. We'll say f of x will become larger than g of x. So the graphs will cross or intersect. Okay. If that is exceptionally confusing, let me draw a quick picture and then we'll be done with this problem. So in orange, I'm gonna draw g of x. So we know g of x has a bigger y-intercept, so it starts off larger. So I'm gonna say it looks something like this. I'm gonna draw f of x in blue. So f of x starts off smaller, but the growth rate is larger. So what's gonna happen is something like this. And then at this point here, whatever it is, they intersect.